In the next question, I ask you to write a mix function that reads an array of an integer. So your function receives two arguments, the authors of the array and the number of elements that you want to read and store in the array. This is the summation of one of your friends. Okay. She declared an array with a maximum size of 4000. We have one variable Rn and some messages here. Again, must the user to enter the size of the array in order to receive elements one by one. She wants to display a meaningful message on the screen. For example, array index will be entered. Now the next element is array 1, something like this. Through the first message and then with the number of variables for this part, and will be received a score variable Rn. Then the function read array will be called here. But before we read it, we have to initialize or arrange its argument or assign a 0 is filled with the orders of the array and side. A1 is filled by the number of elements, then jump on link calling and invoking with. This is the system called for program exit, which is necessary, and this is the with array. In the beginning of the function, she thought the initial value of town registers inside the stack. So first she moved the stack pointer 3 words the up, and then letters are a 0 and as 1 will be stored in the stack pointer. And before we get back is to the initial value of the registers and put them in the corresponding. Now we put a 0 and a 1 inside 100, and 1 is 1 for certain temporarily, and the T0 is the index loop. Start from 0 when the T0 or index of the loop is equal to the end, we should stop. So branch equal number $70 on a 1. Go to this label with a loop down if they are equal to close that we receive to reach an element. Otherwise we have to read some number and store them. But she displays some message first. This is for array message this part, and then show the number 01 so we can see by the system. Can she print the value of the I, and the next part, the close bracket and column will be displayed. And finally we receive the real number from the keyboard, and it should be stored in our index. So for this purpose the startup of the array is inside is 0, and she used this. So word instruction here. Next time the next element should be in the next index of the array. And we know that each element takes 4 byte or 1 board. So as you can see here, the $sign is 0 incremented by 4. So the next time the 0 points to the second location of the array, and also we have to increment the loop counter, and we jump back to the with array loop. So when this program finished, as I said, the initial value of this theory register will be retrieved from the stack, and the return will jump register to return address will be executed. And we come back to the main program. So let's go into some numbers. 5 is the size of the array. 4, 8, 6, 7, 2. As you can see, 4, 8, 6, 7 and 2 are a store in the array location that I declared here. This is my array. And this field by this function. Read array. In the fifth question, I ask you to write a MIPS function that reverse the order of the elements of the input argument array with the size of the dn. So for example, if the array contains these 5 numbers 10, 2, 5, 7, and 9, then we call the inverse or reverse function. The content of this array should be reversed, so assume that the array size is equal to 5. This is the array initialized with this number. This is the function reversed and this is how we can call it in the MIPS jump and link. But before we call it, we have to arrange its input arguments, the address of the array store in a 0 and this number of elements store in a 1. And this is the exit system call and the reverse function is thought from this location. How we can reverse the content of the array? We need the loop to start from the beginning till the middle of the array. The first element and the last element of the array should be swapped. Then we go to the next location or second location of the array and one before the last element. So I need 2 pointer. One start from the last element of the array 1. Start from the beginning of the array. The pointer that point to the start address of the array will be moved to the forward each time, and the pointer that points to the end of the array will move one location backward and this operation should be repeated 10 divided by 2 times. So the start address of the array is stored in temporary register 3 and size of the array will be multiplied by 4. And then we add it to the start address of the array. By this way, we find the last byte of the array address of the last location of the array, but the last byte in the array. In order to come to the last element, we have to subtract 4 unit from this address. So now T3 points to the last element of the array and also assign a 0 points to the first element of the array in order to repeat only and divide by 2 times the A1 will be divided by 2 by performing shift right logical operation. So by this way the RT2 now is the array size divide by 2. So we will repeat until T2 becomes 0. For example, if the size is 10, now PT2 is 5 and each time we decrement 1 unit from this loop counter. So when it is equal to 0, we will come to the reverse loop down label. And now 2 elements from the beginning and end should be swapped. So load 4 from the beginning and from the end and store them in $90, 0 and 0.1, then swap them and put them in the reverse order. The A0 moves forward 1 unit, so each unit has 4 bytes, so we have to add 4 unit to the A0. To go to the second element and to 3 should move backward 1 location. And again, since each element takes 4 byte, we subtract 4 units from this pointer and this operation will be repeated array size divide by 2. We come back to the reverse and when the PT2 or the loop counter becomes 0, we come to this point. And we turn back by jump register $sign the term address. We come back to the main point. Well, let me run it. As you can see, the content of the memory becomes 5, 4, 3, 2, 1. And in the beginning it was 1, 2, 3, 4, 5. Let me change it. The 10, 20, 30, 40, 50. Pay attention that this number will be displayed in hexadecimal. So 32, 3 times 16 plus 2, 48 plus 2 is 50. So this is 50. The last element. This is 2 times 1632 plus 4, 41 times 60 plus 40 or 30 in the decimal format. This is 20 and this is 10. So the content of the array is reversed. In the question number 6, I ask you to write a function that receives an integer as its argument and return the number of its divisor. If you interpret well as the input argument, the number of divides there should be returned, which is 6, 1, 2, 3, 4, 6, and 12ths are the divisor of number 12 include argument of. The function is a 0 and the return value will be received from the outside 0. So here is the solution of one of your friend again. First you show a message and with input number from the keyboard storage in the variable n and then jump and link number of divisor function. After function and work, the result will be retrieved from V0 and stored in the result and also display on the screen again for printing the result. She also claimed the input argument. So the output will be in the format of, for example, number of divisors of 12 is 6. This is the number divisor subroutine, a function that $90 is used as the index and the sum V0 used as the counter. So whenever we find a device there are some V0 will be incremented by 1. Also, this is the output of the function. So if the counter becomes greater than the input argument, we should come to the last labor or the spot and the loop will be finished. Otherwise divide the input argument by counter. Move from higher register to RT1 and check it branch not equal 0. If the T1 is not equal to the 0, this is the reminder. If the reminder is not 0, come to this location. Otherwise add 1 unit to the V0 or the counter of the divisor. Anyway, for both of the case, we come to this point and we have to increase the counter I++ in 5 and come back to this labor number divisor with. And then there I become greater than NW or greater than the input argument a 0. The system jumps to line, jump register, sign RA and we will come back to the main protocol. Let me run the program, for example, number 24. It has 8 devices 1, 2, 3, 4, 6, 8, 12, and 24. For example, 1024. We know that it has 11 wiser. 1248. 1630 264 128. 256 512 1024.